In our last session, we had a short quiz, and we didn't get to a formal lesson. There was a video lesson, and I'd like to believe that you watched it, but if you didn't, I'll recap some of that and move forward with the lesson. Hopefully by now you know that when we graph linear equations, which we haven't started the actual graphing yet, we're going to look at the slope. And we're talking about this rate of change. It could be rising from left to right, positive, falling from left to right, negative. It could be a horizontal line, which is a zero slope. So again, this is a horizontal line. Or if we have a vertical line, it's undefined. So these are the four different linear presentations that we're going to look at. We can know something about the slope of the line or the presentation of the line by just finding the slope. Without even graphing, we'll know whether it rises, falls, is horizontal or vertical based on the value of m. So let's find the slope. And we recall m is equal to, and again, in the beginning, you may want to label your points. The first coordinates are your x1, y1. The second are your x2, y2. I then plug them into the formula. The slope formula is y2 minus y1. We're talking about change, the change in the rise over the change in the run. We're going to get a ratio. Please do not convert these to decimals as I saw in some of the homeworks. So slope is equal to -6 minus a -4 over 1 minus 3. Now we do the math. When we look at this top or change in y, we get -6 plus 4. We add the opposite. We add this opposite here. We get plus a -3. Now we'll simplify and we'll get -2 over -2, which simplifies to 1. So slope, m is equal to 1, which means I'm going to go up 1 over 1 because any whole number can be written as a ratio over 1. Since m is greater than 0, we know it is positive. All right, that's pretty obvious. And we know that it's going to rise. It's going uphill. So we know something without even graphing it. We know that it's going to have this type of presentation. Let's look at our second one. Again, we use the slope formula. Change in y, that's 5 minus a -1 over the change in x, or the run, which is 2 minus 2. Again, we add the opposite. We get 6 over 0. Now, if you recall from the video lesson, and in general, we can never divide by 0, so that anytime 0 is my change in my run, we're going to have a slope that's undefined. Because we know the slope is undefined, we know it's going to be a vertical line. So again, without even drawing it, we know something about what this line represents. So here are those statements, and I believe this was in the previous slide as well. A line with a positive slope rises. That means that m is greater than 0. The slope is greater than 0. A line with a negative slope falls from left to right. The line with a slope of 0 is that horizontal line. And the line with an undefined slope is vertical. And again, my reminder to you was that when the slope is 0, it's horizontal. They both have z's, so if you can remember one, then it follows that a vertical line is undefined. Okay? So now we know that without even graphing, we can tell what that line's going to look like. And now we can classify these lines without graphing. So again, the slope of a line tells you more than just whether the line rises, falls, or is horizontal or vertical. When I look at the slope, I can compare the slopes, and it tells me about the steepness. And I've graphed these two here, and this is now the quick graph without doing the function table, and I started with my y-intercept, well, pretty much, and then I go from there up and down. So these were just graphed kind of quickly, all right? These were not exact representations. As we look at these two equations of the line A, y is equal to 2x minus 1, and I've graphed that one for you, and I used what we call a quick graph, which we'll be learning in about another week or so. And the second, line B, y is equal to 4x plus 2. I can tell something about the steepness of the line just by looking at the equation, not even graphing. If you notice, line B is steeper than line A, and you'll notice that line B has a larger number than line A. So if we're looking at the slope, it can tell us about whether it's positive, negative, zero, undefined, or if we're comparing how steep a line is. So here is the general rule for two lines with positive slopes. The line with the greater slope is steeper. And for two lines with negative slopes, the line with the slope of the greater absolute value is steeper. And we'll continue to reinforce this as we go forward. Now comes like an important part that I didn't get a chance to discuss yet. Two lines in the same plane are parallel if they do not intersect. So parallel lines, they're two lines that will never cross, never intersect. They have a special relationship with their slopes. The slopes are the same. So I could have a slope of a line y is equal to 3x minus 1, and I could have a slope y is equal to 3x plus 4. And since the slope, which is 3, is the same in both, those lines will be parallel. There's a second important relationship we want to look at, and that's perpendicular lines. Well, perpendicular lines form right angles when they cross. So, two lines in the same plane are perpendicular if they intersect to form the right angle, and the slopes of these two lines are what we call negative reciprocal or opposite reciprocals. We're going to investigate that in a moment. Before we can talk about that, we have to know what a negative reciprocal is. Basically, you just need to change the sign and flip. So, if I have a slope of a negative 3/2, it's going to go from negative to positive, and it's going to flip. If it's a negative 1/7, it's going to go to positive 7/1, or just 7. If I start with a slope that's 4, and I want to know the slope of a line that's perpendicular, I will change the sign and flip. That's the reciprocal. One last one. If I want to know the slope of a line that is perpendicular to 5/3, that slope will be negative 3/5. So we change the sign and flip. If I were to give you an example, and I'd say y is equal to 2/3 x plus 1. I know that the slope here is negative 2/3. Sorry, not negative, positive. The slope of a perpendicular line will be the negative reciprocal. I can change the sign and flip it. Let's see another example. If I give you a line, y is equal to a negative 2x plus 6, my slope of this line is a negative 2. The slope of a line that is perpendicular means I'm going to change the sign. It's now going to be positive, and the reciprocal of that would be 1/2. So y is equal to 1/2 times x plus 1 plus 4. The y-intercept does not matter. So we're going to be looking at some equations, and we're going to decide whether they are parallel, perpendicular, or neither. So what do we need to do? We first need to find the slope on these problems. So let's first calculate slope. M is equal to 4 minus 0 over 3 minus a negative 5. And again, I simplify and I get 4 over 8 or 1/2. So now if the second one is 1/2, then those lines will be parallel. If the slope of the second one is a negative 2, they're perpendicular. And if it's neither of those, then they're neither parallel or perpendicular. So let's look. Negative 7 minus 0 over negative 2 minus 3. This gives me a negative 7. Add the opposite over negative 5, and we see that this is going to be 7/5. So this is neither, because the slopes are not the same and they are not negative reciprocals. Now we could also test which is steeper. That's another thing that we'll do, but I'm going to stop here because the video is getting a little long, and we'll discuss it more in class.